To promote sustainable development, after undertaking research projects and consultations in 2014, the Drainage Services Department moved forward with relocating the aging Sha Tin sewage treatment works into Caverns. The project is expected to be completed by 2031. Upon completion, not only will 28 hectares of land be released for other beneficial uses, the current issues relating to landscape, odor, and aging facilities of the existing sewage treatment works will also be resolved. The upcoming Sha Tin sewage treatment works will be the largest sewage treatment works project in Caverns in Hong Kong. The relocation project will be undertaken in 5 stages. The Stage 1 works, site preparation and access tunnel construction, have commenced on 28 February 2019 and mainly deal with site formation and construction of tunnels and access roads. On account of the narrow access road for the construction works, and in consideration that the cavern area is situated in the vicinity of the neighborhood, the engineering team should, in addition to ensuring the construction safety and environmental protection, endeavor to promote stakeholders' understanding of the project operation and minimize its impact on the community. Furthermore, to promote Construction 2.0, the engineering team has also applied considerable innovative technologies so as to enhance the construction quality, management efficiency, and project performance. Let's go and have a look. To facilitate the transportation of numerous rocks produced during the tunneling and to minimize its impact on traffic, we rerouted the footpath and cycle track to the opposite side. Based on Building Information Modeling, BIM, the engineering team has designed and simulated the construction of retaining walls, road pavement, and street lighting installation works to accelerate the project progress. Since January 2020, the temporary footpath and cycle track have been open to the public. We also took the initiative to utilize the solar-powered streetlights to reduce the impact of the excavation work and to shorten the construction period. These measures were well received among the residents and the district council members. Upon completion, we initiated the Hall Road reconstruction on the other side. To identify the underground facilities more accurately, we combined measurement data, 3D scanning technology, BIM and 3D printing to simulate the construction of trenches on the roadside, and validated the feasibility of the design before moving on with the construction. At the beginning of the construction, workers had been assigned to remind the pedestrians and cyclists to use the opposite road instead, so the public would not be messed up. To alleviate the impact of the construction trucks on the traffic in the district, this temporary vehicle bridge plays an important role. Although the temporary bridge is not long, it is vertically in between the Tate's Cairn Highway flyover and A Kong Kok Street. The engineering team has specifically adopted design for manufacture and assembly to prefabricate components for reducing the on-site construction time. Besides, BIM and advanced steel were respectively employed to redesign the bridge deck components. 3D printing models were utilized for trialing the assembly and simulating the entire lifting process to ensure that the 2 cranes operate smoothly when they are performing at the same time. At last, the duration of intermittent road closure was eventually shortened from 6 nights to 2 nights, and it only took 10 minutes for every road closure and lifting. Time was perfectly managed that even the district council members were amazed in their actual observation. There were not only green climbing plants on the bridge to promote greening, automatic sprinklers were also installed for dust prevention. Accompanied by the noise barrier reconstruction works at A Kong Kok Street, these measures showed that the engineering team was dedicated to minimizing the impact of the temporary vehicle bridge on the residents nearby. Since the hillside was large and close to the residents, it was not easy to achieve the site formation progress, exterior appearance, and environmental protection at the same time. Apart from adopting BIM to design and simulate the construction of retaining walls, we have also laid green nets and sward on the hillside. The AI used to monitor air and humidity will activate its sprinkler system and the fogging machine if necessary. The district council members and villagers also worked together with us to turn the recycled plastic bottles into potted plants to decorate the hoardings. See, so many people took photos here. You can tell how much citizens liked it. Upon the completion of the site preparation, we then proceeded to the most important section of the contract, the tunnel excavation. As the site was exposed and close to the residential area, we paid extra attention to blasting, excavation, and piling works to prevent environmental issues. Apart from the regular inspection performed by the independent environmental checker, our site workers also stepped up the inspection on noise and air quality. Additionally, we had installed mobile noise barriers and a special blast door to minimize the noise and dust resulting from the project. By utilizing automatic groundwater monitor devices, we reduce manual monitoring works. Manpower reduction can be achieved while securing the safety of workers. As such, the effectiveness of slope management is further enhanced. This access road connecting Alkankokshan Road and the ventilation shaft was almost shelved because of the opposition from Harmony Manor. After a series of negotiation, we have assured their confidence by introducing effective noise management measures and offering detailed explanations. Eventually, they became supportive and even sent us thank you letters. On the matter of construction, as the slope was too steep and the haul road was narrow, it was very difficult to arrange the construction and material transportation at the edge of the cliff. In this light, we have used the tower crane to lift up the concrete, benefiting the transportation in terms of the time, complexity, and efficiency. Since the Community Liaison Center, located next to the Muijilam Road, is closer to the residents than the Caverns, we adopted the innovative, modular integrated construction to minimize any nuisance caused. With the concept of factory assembly followed by the on-site installation, we reduced the installation process to 2 days. Coupling with BIM, precise calculations of materials were made to avoid waste and to shorten the construction period. The construction of the center had been praised for being efficient and of excellent quality, like magic. Apart from acquiring project information from the center, the residents can also participate in activities to engage in more interactions within the neighborhood. Voluntary organizations can borrow the facilities from the center to serve the community. Outside the center is a park paved with stones and wooden products made with trees felled during construction. Along with plenty of butterflies attracted by the newly planted flowers, a comfortable resting place can be enjoyed by the community. Under the new engineering contract, the entire engineering team upholds mutual trust and always encourages discussion. 2 partnering workshops were organized in November 2019 and June 2020, respectively, to provide the frontline officers with the opportunity to communicate directly with the management, smoothing the workflow. We even developed our own electronic document management system, electronic request for inspection and survey checking system, electronic site diary, electronic safety inspection system, radio frequency identification system, 2-dimensional code, and a common data environment to form a digital work supervision system. Apart from going paperless on site, the smart solution would foster a convenient record tracking and follow-up system. With CAVE, the 4D immersive system, the management could easily get updated on the project progress and present the project to stakeholders more effectively. In addition to holding community liaison group meetings, we also announce the project progress and traffic arrangement to different stakeholders through various means, such as meetings, our website, and our social media channels. Well informed and rest assured, the residents had also turned to be supportive regarding the project and even invited us to attend their activities. We would even discuss improving the community facilities and creating a more comfortable environment through minor works. We care deeply about the safety of our workers. The AI system, as mentioned, can not only monitor the weather, but also remind the workers to wear a safety helmet before entering the worksite. BIM tablets could visualize the work procedures so that the workers could fully understand all the procedures and avoid dangerous situations. Using CAVE and virtual reality, workers could even receive the training in a safe and realistic setting and learn about the safety measures more effectively. Environmental measures are indispensable. To monitor the noise level and air quality during construction, we have engaged not only our staff, but also an independent environment checker. Additionally, we also upcycle the trees collected from the construction site, turning them into furniture. Long leaves were made into brooms, and fine leaves into fertilizer. Our broad applications of solar energy facilities, such as solar-powered streetlights, mosquito traps, and pest repellers, greatly help to reduce energy consumption. With our effective management and application of innovative technology, the impact of the COVID-19 epidemic on the construction had been greatly reduced. We would surely strive for excellence and achieving greatness.